Hi there, my name is Emmanuel Enya, and in this video tutorial I will be showing you how to set up Hilt on your Android project. So sit tight and follow along. Right, to get started, I'll recommend you have a fair knowledge about dependency injection in relation to software engineering. Also, I'd like you to have a little bit of knowledge about Dagger. So basically, Dagger is a dependency injection library written in Java. And finally, this is not a recommendation, it's a must-have. You need to have Android Studio 4 upwards to be able to use Hilt. So what is Hilt? So basically, Hilt is an Android library for implementing dependency injection automatically. So Hilt takes away the effort in writing lots of boilerplate to set up your dependency container. Why use Hilt? One, Hilt is built on the popular Dagger library, so it gets to leverage on its compile time dependencies validation and also its runtime performance. Hilt also defines the standard way to do DI on Android. Prior to Hilt, Dagger was the recommended way of doing DI on Android. With Dagger, there were several approaches to set up components for your dependencies. While this flexibility may sound cool, this issue arises when you move from one project to another project and the method of configuration are quite different. So it's make things difficult to get started with. And finally, it's pretty easy to set up compared to Dagger. So let's get started. So first thing, clone this project from GitHub. It's a starter project I've created. Once clone, switch to the mvvm-hilt branch, so that's where the starter code will be. Then you run the project and also add the Hilt dependencies to Gradle files. But not to worry, I already have these dependencies added in the starter project. Alright, so I have my Android Studio open and I have cloned the project successfully. Currently on the mvvm-hilt branch. So let me walk you through the app. I'm going to launch it right away. So basically it's a tags to do app where you could add tags, you could save tags, you could mark as complete, you can update tags, you can as well delete tags. Alright, so that is that for the demo. So if I walk you through the code base, you see currently that we are implementing dependency injection manually. As you can see here, we have our app container. So this is our app container class. This class is actually a container for our dependencies. So the dependencies we provide to the entire application is held and managed by the app container. So our task now will be to migrate our project from using manual dependency injection to using Hilt. As you can see, we have 3 dependencies already listed out here. So if this project grows larger, the container gets bigger and bigger and gets difficult to manage. So the app container is defined or is instantiated in our application class, so it could be tied to the application lifecycle. But since we are not doing that anymore, we'll get rid of it. We'll get rid of this. And also delete the app container class. With the app container gone, we need to start implementing configuring Hilt on our project. So to get started with Hilt, we need to annotate our application class with @Hilt Android app. So what this does is it initiates code generation for our project. It begins to generate code for our dependencies. And also at this point, an application level component is created for our project. So you could see a component as some sort of container where dependencies are stored. Alright, with that done, let's go back to our task list fragment, because it is the first fragment that appears on the app once it launches. Already you can see we have an error, that unresolved reference, so we need to get rid of every reference to the app container because we are no longer using the approach of manual dependency injection. So get it off, and also get this out. Now with our app container entirely gone from the task list fragment, we need a way to start injecting dependencies into our fragment. So to begin injecting dependencies into our fragment using Hilt, we need to be able to tell Hilt about this fragment. We need Hilt to be aware of this fragment. So for Hilt to be aware of this fragment, we have to annotate this fragment with at 100 entry points. So this annotation informs Hilt about this fragment, that it's ready to receive dependencies. And also, what happens with this annotation is Hilt creates a component for this fragment. So any 100 class with the annotation of at 100 entry point, automatically Hilt creates a component attached to its life cycle. Now with Hilt aware of our fragment, and bearing in mind our fragment depends on our task view model, we need also to inform Hilt how to inject our task view model. But firstly, we have to change this to a lazy implementation. This is still the regular way we get view model. Over to our task view model, we need to tell Hilt how to inject our task view model. Typically in Dagger, we normally use the regular inject annotation, but because Hilt handles creating of a view model for us and also creating of the view model factories for us, there's a special annotation called view model inject. So with this, Hilt knows how to create a task view model. But that's not all there is to it. Task view model also depends on a task repository. So task view model has a transitive dependency on task repository. So we also need to be able to tell Hilt how to create task repository. If we click open on task repository, at this point I like to state that one way of providing binding information to Hilt is by using constructor injection, using the @inject annotation. Using that tells Hilt how to construct those dependencies. However, for interfaces such as this task repository, we cannot use constructor injection because interfaces do not have constructors. So another way to provide binding information to Hilt is by using modules. So this concept of modules, it's more like a container where we tell Hilt how to provide dependencies for us. So over to our DI modules, over to our DI package, we create a class called modules. let's define an app module class. Now for Hilt to be aware of this module class, we annotate this class with add module, and also we tell Hilt where to install this module using the add install in annotation, and we specify the application components because we want this module to be tied to the application component. Now let's define our dependencies. And then tags repository. So we use add binds to inform. We need to make this abstract too. So we use add binds on the method to inform Hilt about this dependency, that for every type of tags repository it should provide the tags repository implementation. So anywhere Hilt sees tags repository, it's going to create tags repository implementation for this type. Alright, so Hilt is now aware on how to create tags repository. So if we click open on tags repository implementation, we realize we need to fully tell Hilt how to create this implementation by annotating the constructor with @inject. So now Hilt is fully aware on how to create tags repository implementation. And that's not all. Repository implementation depends on the local data source. So we need to also tell Hilt how to create the local data source. If we click open on this, we can tell Hilt about local data source by using the @inject annotation. And also the local data source depends on the app database. If we click open on this, and we see that the app database extends the room database. So our app database is actually constructed in this block of code here. So actually you see here that we do not have control over the construction of our app database. Remember I said earlier that we cannot constructor inject an interface. The same thing goes to classes we do not own. So for classes we do not own, classes that comes from a library, we cannot constructor inject them. So for cases such as that, we use modules. So let's take this out here to the module, and then we get rid of all of this. Back to our modules file. So let's create a module called db module. As we did for the app module, let's tell Hilt about this module with the @module annotation. Also inform Hilt where to install this module. Alright, Hilt is now aware of this module, so let's define our dependencies here. So fun room db of type app database. We want to return this So our room DB depends on the context. So we pass in the context via here and then get rid of this. So for Hilt to be aware of this dependency of our app database, we annotate the method with @provides. You may be wondering why @provides here in DB module and @binds in app module. So I could have just inserted room DB method in app module, but that will not work because we cannot have @binds and @provides in the same module. Hence the need for the separation. Our room DB depends on a context and we define context here. However, Dagger does not know how to create the context, but luckily we can annotate our context with application context. This qualifier, it's more like a default binding provided to us by Hilt. So out of the box, Hilt can pass in the application context for us, so we don't need to worry about how the context is created. Alright, so that is that. I think we have everything set up properly now. And also one thing I would like to show us before we demo the app, it's about a concept called scope. So we could actually scope our dependencies to a particular component. So we have predefined scopes such as singleton. So we could do same thing here for our repository. So this singleton scope, what it means is throughout the application lifecycle, we'll have only one instance of app database and also one instance of tax repository. So I guess we are done setting up our components. We need to change the implementation in other classes as well, in other fragments. So we go to add tax fragments. We get rid of the reference to app container, and since this fragment depends on our view model, we need to inform Hilt about this fragment using the @100 entry point. Then we change this to a lazy implementation. We'll do the same thing for the edit tax fragment. Let's inform Hilt about this fragment using the 100 entry point. Get rid of reference to the container. Then we change this. One last thing before we test what we've done so far. So bear in mind that the fragments in use for this project are all hosted on the main activity. And what that means is we need to inform Hilt as well about the activity hosting this fragment. So to do that, same thing, we annotate the main activity with 100 entry points. So with this, Hilt is aware of the parent component for those fragments. And this we are done. So let's check it out. Let's run this. Right, so everything still works just like before. We can add, we can delete, we can mark as complete, we can update. So So great. So we still have a functional app working as before when we tested it initially. But the only difference here is we are no longer using manual dependency injection, but we are leveraging on Hilt. In the course of this tutorial, we've covered some concepts in Hilt. We talked about modules, we talked about components, scopes, and also Android entry point. So I believe with this concept and what you've seen me do so far, you could begin integrating Hilt in your Android project. Thanks for watching. If you learned a thing or two, don't forget to like and subscribe to the channel, and most importantly, your feedback in the comment section. Thank you.